Okay, so we dealt with derivatives, minimum of a function. Now we're gonna look at partial derivative, gradient vector, Hessian matrix, and we're gonna look at convexity. Convexity is very important in machine learning, and you'll understand why. So how do we do partial derivatives? I put an example down here. X squared plus y squared is minus 2xy plus 1. Yeah. So you see this function, we could call this function z, is a function of x and y. Yeah. So we can derive this to x. We can say dz dx, and a partial derivative we denote by this. Yeah. If we differentiate with respect to x, we consider y as a constant. So in this case is, I differentiate this one, this is a constant. So differential of a constant is 0. Y is a constant, so it's minus 2y, and the derivative of 1 is 0. But you could also derive z with respect to y. And now x is a constant, so that gives me 2y minus 2x. Yeah? Now, so these are the two partial derivative first order of z, right? Now, we define the gradient of f equals, it's the vector of the two partial derivatives. Yeah? So is 2x minus 2y, and here you have 2y minus 2x. Yeah? So the gradient is a vector. Yeah? Is the vector of the first order derivatives. Now, so we call this gradient. Now, where the gradient is 0, this we call stationary points. Yeah? The best way to understand this is that you have a sort of a plane. In 2 dimensions, you have a plane. And maybe there's a little bump in that plane here. And there is a ball that gets stuck. So that's a stationary point. It's a point wherever you put the ball will not be moving. Okay? So that's the gradient. Very important, because gradient descent, again, is the most widely used algorithm in machine learning. Okay, now let's rewrite that function. X squared plus y squared minus 2xy plus 1. And we have the first order derivatives, the z by the x equals 2x minus 2y, and the z dy equals 2y minus 2x. Okay? Now here again we can go to the second order derivatives. So this you can derive a second time with respect to x. Yeah? And then the outcome is 2, because y is a constant, so it's 2. And you can derive a second time, but now with respect to y, and that means that the outcome is minus 2. But you can do the same here. Yeah? So d squared z dy squared equals 2, and d squared z dy dx minus 2. Yeah? So these four are the second order derivatives. So, and this is what we call, this is what we call a Hessian. This is the Hessian matrix. It's actually the matrix of the four second order derivatives. Is 2, minus 2, 2, minus 2. Yeah? This we call the Hessian. Now, the Hessian tells us something about curvature of a function.